Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Higher Tier Component 2 paper from autumn 2023. This paper is worth 120 marks in total, and this is the fifth video of 6. It will focus on questions 18 to 20, which account for 21 of these marks. Eduqas Component 2 papers are calculator papers, so a calculator should be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 18. A car driver is having a tyre replaced at Eduqas garage. The waiting time in T minutes is inversely proportional to the square of the number of mechanics working on that day. If there are 3 mechanics working, the waiting time is 38 minutes. Part A, find a formula for T in terms of M. Okay, so we're working with inverse proportion here, guys. So T, the waiting time, is inversely proportional to the square of the number of mechanics, so to M squared. So T is equal to K over M squared. K is our constant of proportionality. So we are given an M value and a T value that corresponds. So 3 mechanics, the waiting time is 38 minutes. So I'm going to substitute those two values in to find K, my constant of proportionality. So T is 38, M is 3, but we're working with M squared. So K must be equal to 3 squared multiplied by 38. So 3 squared multiplied by 38 is 342. So K is 342. So my formula for T in terms of M is this, but with my K value now included. So T equals 342 over M squared. Part B. The garage wants to reduce the waiting time to no more than 12 minutes. What is the least number of mechanics that should be working to achieve this? So remember, time is T, mechanics is M. We've got a formula here now that gives the relationship between time and mechanics. So we're going to use that. Okay, so we're looking for the least number of mechanics that should be working to achieve a time of 12 minutes or less. So I'm going to rearrange this formula now to solve for M. Okay, so I'm going to substitute in my T as 12. So 342 over M squared. When I multiply by M squared, I'm left with this. But to find M squared, I'm going to do 342 divided by 12, which is 28.5. Now M squared, but I want to know the number of mechanics, so I'm going to square root that value because that's M squared. So I'm going to square root my answer, which gives me 5.3385 mechanics. Well, I can't have 5.3385 mechanics, so I'm going to need 6, I believe. And I'm going to make it nice and clear, because I've used a lot of space, that it's 6 mechanics. Question 19. So we have a diagram not drawn to scale, so we can't measure anything from it, but we've got some side lengths and some angles labelled. It tells us to calculate the size of angle CBD. So remember that little symbol? That's the angle that we're looking for. So if we go CBD, we're looking for this angle here. Okay. Now we can work with these two separate triangles, which is useful because actually to find this angle, I'm either going to use the sine rule or the cosine rule, because neither of these triangles are right angled. So we're using further trigonometry. But to be able to work with this triangle that includes my angle of X that I'm looking for, I need more information. Okay, so there are a couple of options here. But the first thing I'm going to do is I'm going to calculate the length of BC, and I'm going to do that by just using this triangle here. Because I've got 2 sides in the included angle, I can use the cosine rule. Okay, so I'm going to find BC. So BC squared equals 8.3 squared plus 6.4 squared, subtract 2 times 8.3 times 6.4 times cos of the angle, which is 71. So you could stick all that in your calculator, but what I am going to do is just calculate through a few values so that I don't make a mistake entering that big thing into my calculator. So 40.96. So 2 times 8.3 times 6.4 is 106.24 multiplied by cos 71. So 68.89 plus 40.96. So this simplifies a little bit further to 109.85 subtract 106.24 cos 71. Now I am going to stick that into my calculator. So 109.85 subtract, and I'm going to put this in a bracket just to be safe. I'm always a little bit paranoid when I'm dealing with things. I'm closing my cosine bracket and I'm closing that bracket. When I've got a negative there, I just put an additional bracket in for safety. So this tells me that BC squared is 75.26163927. I want BC, so I'm going to square root this, guys. So 75.26163927. Haven't deleted it because I want to make my life easier. So square root of my answer is 8.67534667. So that's BC and it's in centimetres. So I'm going to put 8.67. It would be rounded differently, but it's just so I remember that this links to this. Okay. Now we need to look at this triangle now. So triangle CBD. So I have two sides. The included angle is x. So what I could do is I could use the cosine rule, but then to solve for the angle, or I could use the sine rule, which is this angle and this side, and then this side to find this angle, and then take them away all the way from 180. So whichever works best for you. I'm going to use the sine rule, okay? And I'm going to use the sine rule with this side and this angle, and BC and this angle, and I'm using it to find this angle, guys. So when I'm using the sine rule to find an angle, we flip it upside down. So it's going to be sine of my angle that I'm looking for. So let's call that y. So sine of y over the corresponding side is equal to sine of 68 over its corresponding side. So sine y is equal to 8.67 multiplied by sine 68 over 11.1. But then to get y, I would do the inverse sine of all of this. So 8.67 multiplied by sin 68 over 11.1. So I'm going to do that in my calculator, guys. So to get the inverse sine, press shift and the sine button. So I have 8.67 multiplied, and then I'm going to use the fraction button for this. Sin 68, close that bracket. 11.1, arrow away from my fraction, close the big bracket and press equals. So y equals 46.40281709. Okay, so let's go 46.4 degrees for that angle y. So now this is a triangle. Angles in a triangle add up to 180. So 180 take away 68 and 46.4 will give me the angle that I'm looking for, x. I haven't given myself a lot of space, but we're going to write it down anyway. So 180 subtract 68 subtract 46.4 equals. So 180 minus 68 minus my previous answer is 65.597. So I'm going to write that as 65.6 on my answer line. Question 20. So we have a diagram drawn here and we have got a region identified and 3 straight lines have formed that region. So this is inequalities, guys. So inequalities from regions. Part A, complete the following table. So we've got a table here to show the inequalities that describe the shaded region above. And they've given us one. They've said y is less than or equal to 4. Okay, so y is less than or equal to 4 is this line here. Y is less than or equal to 4. It's a horizontal line through 4 on the y-axis, and the part of the graph that's shaded is below that, so it's the values that are less than or equal to 4. We need to find the inequalities that are this line and this line. So this is the easiest one to work with. So a horizontal line through the y-axis is a y line. A vertical line through the x-axis is an x line. So this line links x and -2, but what we need to recognise is what's happening. So it's a dotted line, so we're not going to have an equal to symbol, but we're interested in this side of the line because that's the bit that's shaded. So the values of x on this side of the line get bigger, so they are greater than -2. We don't put an equal to because it's a dotted line, but I'm going to write x is greater than -2 in there. So now the final line that we're working with is this line here, okay? And it's a straight line, so it's going to be in the form y equals mx plus c. Remember that m is your gradient and c is your y-intercept. So the y-intercept of this line is nice and easy. It's +1. But we need to figure out that gradient. So we're going to identify 2 exact coordinates. So I've done one of them there. 0, 1 is a coordinate. And then this point on the line here is at -1, -2. And I'm going to form a triangle here to identify the gradient of this line. So the gradient is the change in y. So the change in y over the change in x. So the y has gone from -2 to 1. So that's a change of 1, 2, 3 in the positive direction. And then it's gone from -1 to 0, which is a change of 1 in the positive direction. So the gradient is 3. So y equals 3x, add 1 is the equation of the line. However, we're working with inequalities. So we need to look at the area that is shaded on this side of the line and decide whether we're going to be using a less than or an equal to, a less than or a greater than symbol to start off with. So because it's at above the line, we are using a greater than symbol. So y is greater than 3x plus 1, but it's a solid line. So we need that equal to as well. So y is less than or equal to 3x, add 1. Part B, the line AB. So this line AB is shown on the diagram. The diagram's not drawn to scale, so we can't measure anything directly from it. They want us to show that the equation of the perpendicular bisector of the line AB is 4y equals x plus 9. So to be able to find the perpendicular bisector of the line AB, we need to start by finding the gradient of the line AB. So remember, the gradient is the change in y divided by the change in x. So the change in y, so the y coordinates to start off with, we've got 10 to -6. Now we're starting at 10 and we're going down to -6. So to get from 10 to -6, we've gone down 16 places, okay? And then when we're dealing with the change in x, we've started at -3 and we've moved to 1. So the change in x is a positive movement from -3 to 1, and it's a movement of 4. So the gradient is -16 over 4, which is -16 divided by 4. If you're not sure what that is, let's put it in your calculator. So the gradient of AB is -4. Now we're working with the perpendicular bisector of this line. So the perpendicular bisector has a negative reciprocal gradient. So we change the sign of the gradient and we write its reciprocal. So the gradient of the new line is equal to the positive reciprocal of 4. So the reciprocal of 4 is a quarter, and it's a positive. So that's the gradient of our perpendicular bisector. So this is going to get you a mark, and this is going to get you a mark. Now what we would do is a straight line has the form y equals mx plus c, and we would substitute that gradient in. So we have y equals a quarter x plus c. And then we would use a coordinate that is common to both lines to substitute for y and x to get c, okay? Now we haven't been given a coordinate that that perpendicular line cuts through, but because it's a perpendicular bisector, it's going to bisect this line exactly in the middle. So if we find the midpoint, that's a coordinate that's common to both lines. So we're going to find the midpoint of AB to start off with. So we have got our coordinates here. So to find the midpoint, we want to go halfway between the x coordinates. Now we said that the x coordinates from -3 to 1 is 4. Half of that is 2. So add 2 to -3. The x coordinate is going to be -1. Let's look at our y coordinates. We're going from 10 to -6. We said that was a difference of 16. Half of 16 is 8. So we're going to take away 8 from 10, which gives us a y coordinate of 2. So this is now a common coordinate for the line AB as it's the midpoint, and the perpendicular bisector as that's where it would intersect the line AB at a 90-degree angle. We're now going to use these two values for x and y to calculate the c, the y-intercept for the perpendicular bisector. So y is 2 when x is -1. So -1 multiplied by a quarter is -1/4. So c is equal to 2 plus 1/4, which is 2 1/4 or 2.25. I'm now going to substitute that c value in. So the equation of the perpendicular bisector is y equals 1/4 x plus 2.25. However, if we compare this with what the form they've asked us to give it in, we haven't got a fractional gradient of x and we have 4y. So what we need to do is multiply this equation by 4. Y multiplied by 4 is 4y. 1/4 x multiplied by 4 just gives us x. And 2.25 multiplied by 4 gives us 9. Everything gets multiplied by 4. So we've shown that the equation of the perpendicular bisector of the line AB has this equation.